Hello, today we are going to be looking at two worksheets. First one on sample space and the next one on equally likely outcomes. Okay, sample space. We need a sample space when we randomly pick. That means we have not looked first, blindfolded, or we just didn't look inside from a group. There are more than one objects there and we're taking a small part. We call that sample when we are doing probability. We need, first of all, to list all the possible outcomes. These are called the results. And that is called the sample space. So some language for you to remember. Let's have a look. Now this juggler here is very clever. He's got a tennis ball, football, American football, basketball and volleyball, and he's juggling them. Okay, so we're going to look at this question. What if he drops one? Which ball, outcome, so that's all we're looking for, is that ball that he drops. So first of all, we need to draw a sample space of all of the possible outcomes. So that's every single ball that he is juggling. When you look, you see that the beginning and the end have curly brackets, and between each of the possible outcomes there is a comma. That is very important. That is how it is written. Let's have a look at examples. So, a bag containing positive integers less than 10. Use a highlighter to help you to see the information that is very important. We need to list the sample space when one of the numbers is picked at random. Okay, so the sample space, S equals, sample space equals, and 1 through to 9, they are the numbers that are less than 10, and curly brackets front and back. A different example here, we've got a spinner. We're going to list them all. Every single one of these has to be listed. There happen to be 2 stars, one here and one here. We have to list every single place that the spinner could land on, all of them. So the star will appear twice because there are 2 of them. And the last example, we're looking at 2 coins being tossed. So to help us to understand the sample space, we set up this two-way table here. So 1 coin and 2 coins. The only possible outcomes are heads and tails from either coin, and you might have a head first and then another head, or a head first and then a tail. You might have the tail first then the head, or the 2 tails. And writing it out takes a while, so we accept putting just the capital. So 2 heads, head tail, tail head, 2 tails, straight from this table. Okay, let's have a look at some examples. Okay, your first question here is we have to write down the sample space for all of the possible outcomes. Now we know that tossing a coin, there's a head and then a tail. It is equally correct to write the tail first, then the head. As long as you have both the outcomes written there, order doesn't matter. Flicking on a switch, off, on, off, on. Have a look at the spinner, 1, 2, 3, 4. Normal 6-sided dice, so there would need to be 6 numbers there. Gear stick, make sure you include every single position you could put the gear stick into. All of the keys that are on this keypad. They're not all just numbers. Choosing a letter from mathematics. Now be careful with this. This is that second example we saw where there's more than one of some of those letters. When you do this one, remember you might not knock every pin over, any pins at all, and all the possible scores. Okay, have a go at that. Okay, check your answers. How did you go? Did you remember neutral and reverse? Do you remember these are on your keypad? More than one A, P and X? Did you get all of these? Okay, well done. Let's have a look at the next question. On your next sheet, we're going to do the two ways. So that was that last example we looked at. And this time we're going to do flicking two light switches. And as we saw, it's only on or off. So you need to write that this will be on, won't it? Just like we had in the example. And then when we write it, S equals, remember the curly brackets, a bracket, on, another comma. This continues with this one, it doesn't change, it's head 1, head 2, so you'd just be head 1, head 2, and continued, and then you have to write them all out here. There'll be 2, 4, 6, 8 possible outcomes. Getting longer and longer, but we just want you to write the capital letter, not the whole name. And this one here, there are 9 possible outcomes. So away you go. Okay, have a look at the answers. How did you go? Very much like the coin one first. A little bit longer. Check your answers carefully. Pause if you need to. And the last two. Okay, now we have another set of questions. That's a very big one. Away you go. And the last question offers you no support. You have to set up your own table. Okay. When you're finished, switch it back on again and we'll have a look at the answers. Nothing different, just big. So don't be scared. It just means it takes a little bit longer to do. That's exactly the same process. And you had to set up your same one. Remember, there were 2 die you were told about, and you were told that you're going to have to look at the values. So a 6 plus a 6 is 12. Often in games you play, you use 2 die and you add them. It's impossible to roll a value of 1. And using a 12-sided die, each value occurs only once. And using 2 6-sided die is not the same as using 1 12-sided die. Your probabilities would be different. Well done. Let's move on now to our equally likely outcomes. Deep breath. Okay, these are the ones. Equal means same, so they have the same chance of happening. If you have a look at these 2 spinners, you can see all of them have exactly the same size. All the segments are exactly the same size, so the outcomes are equally likely. This is a non-example. You can see they're different sizes, so they have a different likeliness of an outcome. This one's more likely to occur than any of the little ones, isn't it? So it's got to be even chance for it to be equally likely. Okay, some examples. Rolling a die, and we did the sample space. There are more chances of an outcome of 1 or 2, so different outcomes are not equally likely. This was the sample space. As you can see, it's got 2 1s, 2 2s, a 3 and a 4. So they're not equally likely, are they? There's only 1 4, 1 3, but there's 2 of them. Opening a 20-page newspaper to an even numbered. So you have to actually look at all the page numbers that are there. Is there an equal number of odd and even? So you have to look. Yes, there are. So it's equally likely. Some experiments can be rigged to ensure certain outcomes. This is called bias. Bias comes up in a lot of our statistics. Biased experiments do not have equally likely outcomes. Like the spinner has a bias, doesn't it? These two are more likely. So there's bias. And a normal 6-sided die can be weighted on one side. Therefore, the number on the other side is more likely. Okay, some examples. Waiting for it to... Not happy about coming into focus, is it? Ah, there it goes. Dartboards. You have a look at this dartboard. So it depends, doesn't it? As you can see, they're not equally likely, are they? Because they've got different areas. This one, however, has the same, hasn't it? It's equally likely. This one, these ones are, but that 50 in the middle is different, isn't it? These ones, different again, aren't they? These ones are the same. Oh, they're very different, aren't they? Okay, write down those answers and check you've written the right one. Question 2, you need to write your sample space first. So we're tossing a head or a tail. So remember, curly bracket, head, comma, tail, curly bracket. Each different outcome is equally likely, isn't it? You go through and write all of the sample spaces for these and work out whether or not they are equally likely. Okay, how did we go? So 3 black and 2 green, that's not going to be, is it? A raffle in which 10 participants have 1 ticket only, that's going to be the same, isn't it? Picking a vowel or a consonant, you've got 3 vowels and 7 consonants. Can't be. Odd or even number, from that dartboard in question 1, did you go back to there? There were 5 odd and 4 even. If you checked, not. Odd or even on a 4-sided die containing the first 4 positive perfect cubes. So 1 times 1, 2 times 2, perfect cube. 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4. 2 odd, 2 even. Good. Rolling the following 8-sided die. So you noticed how many 1s, 2s and 3s? Nope. Okay, and the last page. Page 11. Oh, don't you like my fish? Okay. Use the sample space provided and you need to make them. So if you've got 4 numbers and they've got to be equally likely, your 4 numbers have to be the same size. This one here, not equally, so those 1, 2, 3, 4, 5 numbers, as long as they're different, all good. Have a go at all of your questions. See how you go. And the answers equal, not. Yours don't have to be exactly the same as that, as long as they're different. The four-sided shapes have equal amount, but the other shapes are different. So only the four-sided are the same, the others are different. Equally likely, you've got all of those, so make sure the two greens are the same and the two pinks are the same, the two blacks and the two blues are exactly the same. It's biased, so we know there's going to be a problem here. So the circle outcome is twice as likely as the other four. We just add another circle, don't we? So you've got two of the circles and then only one of the other ones. And they need to be equally likely, so they all need to be the same size. Biased again, so we know we're going to have to mess with this. It has double the chance of being spun than the previous one, so 2 is double the chance of 1, and 3 has double the chance that 2 had. So 1 1, 2 2s and 4 3s. How'd you go? All good. Goodbye.